So most welcome to the iSet Robotics MOOC M2, and this is unit number 4. And now we're considering the application of multiple sensors with flow control and the gearing and the powered attachments to solve a problem. My name is Patricia Goos and I will be presenter for this unit. So in the analysis of the problem, you always need to divide and conquer. You have programming increments. Those are each individually tested, and you improve in parts, and then you combine the two parts, and then you test that again, and then there's further rewind and you continue testing. Okay, so in the analysis of the challenge specified, you must analyze the problem, and usually you need to watch the video if there's one to gain an understanding and gather data, and then define the verbs. What are you looking for? Then there's the building structures, and that we've already dealt with attachments, passive or powered, whether we're going to put some gearing into it, and then the other build structure that we need to consider is sensors. Why are we including sensors on our robot, and how to attach them and how to use the input data from the sensor? The programming would then be the movement, describe the risks and the constraints, and is linear repetition or decision required? And then for the sensors, how to include the sensor data in the programming, because there's always parts of the code. Okay, so for the incremental approach, you divide the challenge into a number of parts, and be sure that you're trying what you're trying to achieve. Then you define your initial attempt, you implement and test it, and then that initial one can be modified and then improved. A good example for the problem solving would be to consider the FLL 2020 challenge. There are several missions, but each mission considers what is required, and then a good start would be to say, let me consider the verb. Do I need to carry? Do I need to fetch? Do I take? And then to combine the missions for greater efficiency. All right, so an example would be mission number 1. You need to be able to push something, an innovative project, okay, from base, and it needs to be pushed to a specific place. All right. The two places where it needs to go, the one is shorter. So in terms of efficiency, to get it to where it has to be, the shorter distance will obviously be the better option. All right. In terms of attachments, we'll need a passive attachment because we have to push something. Sensors, I don't think we need too many sensors, because what are we going to use the sensor data for? Is it going to be that more efficient in your programming? The programming itself is describe the movement. The robot must start in base, go forward, leave something behind, and then come back. All right. And then flow control. Is that linear, repetition, or decision? It's just plain linear. And then the sensor, how to include the sensor data in the programming, that you need to consider. So can you see now for mission 2, again, it's a push. You have to push something. All right. You might not need exactly the same attachment as in mission 1, but again, you need to push something. So if you have like a bigger hand, instead of pushing with your finger, it'll be much more effective if you push with your hand. So maybe a passive attachment, almost like a bumper structure, which can push this very gently and very consistently as far as you can go. And then of course, once you have actually finished the first mission and the second mission, then you can take the list and then decide which are the next missions and how do I apply what I've learned to solve all these problems. And so as an overview or a review, you consider in analyzing the problem, you can then identify what building instructions are required or what building structures are required and what programming code is required. And by combining then the build structure with the program or the code that has been programmed, then together that forms the solution to your problem, and then the application of all the learning material. So we've come to the end of unit 4. There's definitely a quiz waiting for you, but there's also an amazing unit 4 challenge. I really encourage you to analyze the problem, see what is required, and then to come up with a solution. You are more than welcome to contact me. Of course, then you can carry on and register for M3. Thank you so much for your attention.